Hello everyone, I'm gonna demonstrate the new features in my program that generates templates for C# projects similar to the ones you find in C++. So the first thing you'll notice is a brand new UI. It is made with the apps Metro component for the Windows Presentation Foundation framework. We can now group our templates in solutions and generate them with other files. So let's open a solution I made to demonstrate the capabilities of the software. Okay, this is a vector solution. Here you have some options and here you have the templates. We can open the templates in editors with simple syntax highlighting. This is another component called Avalon Edit for the VuePF framework. So the cool thing about the program is that you basically generate C# code by writing C# code. If you're confused, take a look at the vector class code. Let me explain. Everything you see here is valid C# code except this symbol, which is $2 one after another. This symbol is parsed by my program and converts the strings inside the parentheses or the strings without parentheses in C# code that will be used in the generated project. So if we go through here, we can see that we declare an array with normal C#. We have a for each loop with normal C#. Inside this for each loop, we are telling the program that it has to write a template that starts with this string and adds another string to the end of it. In this other line, we tell the program to simply add a brace, and then we tell the program to write our constructor, which is another string, public vector2, the type, which is taken from the for each loop, and then we have the parameters. If the type is int, we will have public class vector2 int, public class vector2 int, the parameters int mx, int my, and so on. It's very simple. The only difference is that when the parentheses follow the $sign, it means you can use expressions like strings plus C# variables. When there is no parentheses, it is a shortcut to tell the program to simply transform in template code everything that follows the $symbols. Here we have another part of the solution, which is a static class, vector2 utils. As you can see here, we simply tell the program to write these lines and close the brace here without any kind of special parameter. Then inside the class we have a nested for loop. We have three variables arrays. One for the types we declared in the other file, and one for the types that will be created by the other file. This way we can create an utility class that in a similar way to the file I just showed you, creates methods which can add a type of vector to a completely different type of vector without any generic casting or stuff like that. It's like handwritten code. So it's fast and it's flexible. It doesn't have the limitation that C# generics have. I also added a save before closing pop-up, so it's quite useful. After we are done with our files, we can then generate the solution. Before generating the solution, we have to set a project, which you can do by double-clicking here and finding a C# project. For testing purposes, I'm gonna use the same project as the program, and then we simply double click on generate and if we go back to Visual Studio, we see that the project was modified and we have to reload it. By simply pressing reload, the new files now appear in the project under a folder with the same name as the solution. We can simply open the files. They are quite cluttered, but we can simply use ReSharper for this, and we have perfectly functional vector2 classes. We can have int, float, double, and long, along with utility classes that add the vector one to another. As you can see, the for loops were necessary to have all possible combinations, for example int int, int float, int double, int long, and so on. And the casts are necessary for adding different type of numbers, which couldn't have been done with GenerX. So thank you for watching. I will release the program under open source license on my GitHub page when it's a little more polished.